So at this point, we of course learned a lot about arrays, slices, and maps. And we're almost done, but there are two remaining important Go features you should know when working with arrays, slices, or maps. And for that, I created a new main.go file, empty file basically, except for this function, and moved the maps.go file into a maps folder and assigned the maps package so that we got no package clashes. And in here, in this main function, I want to create a new slice. Let's say a username's slice, where I simply want to store a couple of strings. Now, of course, we can create that slice like this, and as you learned, if you don't assign a length here, it's not an array but a slice, and you can therefore dynamically add new elements with the built-in append function. So we can append Max as a username here, for example, and save that back into our username's variable. And then do the same here with manual. And if we then use the format package to print all that, so to output usernames like this, we should see that slice in the console. So if we run this application, we indeed see that here. That's of course something you already know. Now, what's worth noting about this code here is that when you're creating such an empty slice as we're doing it here, Go will, behind the scenes, essentially also create an empty array. And then once you start adding items, it will start creating new arrays to fit the new content into those arrays and therefore essentially into your slice. Because as you learned in the end, a slice is just a window into an array, therefore behind the scenes, Go takes care about managing those arrays. Now that's of course great, but if you have a scenario where you know that you're going to add a couple of items to a slice that's initially empty, or at least not as big as it eventually will be, then you can also pre-allocate some space for these to be added elements. And that of course only makes sense if you know roughly how many elements you're going to add. But here, where I'm adding two elements, we could make Go aware of the fact that we will add those two elements eventually. Because when we do, Go is able to, behind the scenes, create a bigger array right from the start, and it then doesn't have to recreate those arrays all the time, which is a bit more efficient. And you can tell Go that you need a bigger array behind the scenes by using the make function. You can call the built-in make function to create such a slice. This function then needs a couple of arguments, and the first argument is the type of slice it should create. Therefore, you must not use this literal notation with those curly braces, but instead you define just the type, so that you want a slice of strings. Then you must at least pass one extra argument to make. And the first extra argument you can pass to make when using it for creating a slice would define the length of that slice, the initial length of that slice. With that, Go will go ahead and behind the scenes create an array with length 2, where both elements initially will be null, empty slots, so to say, but where you can now assign elements to those slots. The result of this code here might be different than what you maybe expect though. Because if I now run this code, we got this output here, and as you can see, the empty slots are actually in front of Max and manual. So the two usernames I assigned here do not occupy these slots. And that on the other hand should make sense, because make like this, as I mentioned, creates an array of length 2, and these two elements then are empty here. When we then append new elements, we of course don't add those for those existing slots, instead we append them to the end. Instead, you could now, when using make like this, assign values for these two slots that have been created, like this for example, without make. So if you would not create usernames like this, but instead, as we did before, by using a string literal, you would get an error with that code. Because this creates an empty array behind the scenes, and when you then try to target the first element there, you'll get an error. So if I run this code here, it crashes. So that's one difference of make. You can create an array behind the scenes that already got some slots, which can be helpful if you want to assign values to specific indexes like this. But originally, I talked about a greater efficiency if you let go know about the intended size of the array you'll eventually need. And that's not yet what we're doing here. Instead, you can pass another argument to make when using it to make a string, and that would be the capacity of the array that should be created behind the scenes. For example, 5. Now keep in mind, the capacity is essentially the maximum number of array items and therefore controls how much memory space will be allocated behind the scenes by Go for this array. So this make function call will make sure that Go allocates enough memory space for a string array that takes 5 items, and it will create an array with 2 empty slots. But now with that pre-allocated memory, appending items here is more efficient because with this code, Go now doesn't have to go to the memory and allocate new space. Instead, it can use the existing space because we already reserved enough space. And only once we go beyond the 5 capacity limit here, it'll have to allocate new space. And therefore, using this make function can be useful if you know in advance that you're soon going to add a fixed number of items, or at least a number where you have a rough estimate how much you're going to add, because that then can make memory management more efficient. Now, I'll also say that in many apps that might not matter at all, but it can be an optimization that can make sense for certain applications.